there has 6 towers that are 200 feet tall, 6 of them. You look at the inside of his ham shack and it's like, you think that you've moved to another planet. It is just incredible. So these are all guys, these are top tier guys that put on those programs, and they have a wealth of information. It's really worth it just to listen to it, both for contesting and also DXing. It's a really important thing. So along that line, I thought, and also I've been getting bugged about when are we going to start seeing solar cycle 24 starting to wake up. And I thought it might be just a cool idea just to do a quick review of where we are in Solar 25 and get everybody up to date on what's happening. So this little program, we're going to talk about what is a solar cycle. I need to do a little basic stuff for maybe people that aren't familiar with how important solar cycles are, what they are, how they affect ham radio operations, but a little bit of background before I start getting into the meat of that. So I'm going to give just a quick little review. A little history on what happened on solar cycle 24. That's the solar cycle we just came out of. And we're just starting to move into solar cycle 25. So I'm going to be providing the latest updates by all the professionals out there on what they think we're going to see with solar cycle 25. And also that'll help set some expectations on us for what's going to happen. So what is a solar cycle? Okay, the sun. The sun is this huge ball of electrical charged hot gases. So we kind of think of planets being really a solid. Now, the one miracle thing about the sun is that it's really a really highly dense, when you get down into the core, the density is just incredible, but it's just really at the basis, it's just a bunch of hot gas that's all rotating around itself. It's like a thermal nuclear event that's just swirling with hot gases. So as these gases move, the important part is that it generates some really powerful electromagnetic field. As ham radio operators, all of our RF that we send around the world, those are really, that's an electromagnetic field that we send out. So that's our, how we end up kind of tying our hobby with what goes on in the sun. Okay, the intensity of this cycle varies on a basically 11-year cycle. It's plus a year, minus a year. It's 11 years is an approximation. So don't hammer a nail through that and expect it to be setting some kind of circadian clock out there. So it's an approximation of 11 years. Each 11 year, okay, the sun magnetic field completely flips. So you have these magnetic sunspots out there that they kind of switch their polarity from positive swirl to a negative swirl. And that happens about every year, and that determines when we have a new solar cycle starting. Okay, this 11-year cycle is called a solar cycle, so that's the key thing that we always refer to. The amount of solar activity creates sunspots, and these are these little blemishes, and I have a picture coming up, and I'll show you what an actual sunspot looks like. Okay, these sunspots directly correlates to, well, that's a redundant thing on there. That didn't need to be there. But anyway, basically they create solar spots, they create solar flares, and they create coronal mass ejection. So those are the two things that of interest that as for ham radio operators that provides us some level of interest that affects what happens on radio waves here on the Earth. Okay, so the amount of sunspot directly affects ionosphere ability to refract. And that's not reflect, but refract. So it bends our RF back to Earth. So if we have good solar ionosphere ionization going on, it's going to do a really good job of bending that RF back to Earth. And what does that mean? This gives us this phenomenon that we call propagation, or better known for us, we call it skip. This allows us to bounce or skip our RF off the ionosphere. So this This is what enable us hams to talk around the world. Really, really important for us. So we have kind of two things that we kind of refer to in sunspot terminology. We have what's called solar min. We have solar max. Solar min is when we have basically a sun that basically looks void of sunspots. Not a darn thing going on. So this in this particular condition, we're not going to get much of, if any, of solar activity that's going to end up giving us what we all want. So this is a pretty active sun. This is a little different rendition of the sun with a little different filter on there. You can see off the edges of the sun, you can see this little squirts of plasma that's being squirted out there. Those are little solar flares. And when you get a really big one, those are called the coronal mass ejections. You can also see those white spots in there, and those are going really more like those are sunspots in there. So let's put a different kind of filter on, and we'll take a look at the sun when it's active. And you can see those black spots on there. That's kind of like acne on the sun. Those are the things that we like to see. Those are cracks in the surface. There are openings in the surface that allows electromagnetic fields to take and escape from that and work its way down to the earth and causes our ionosphere to ionize. And that gives us what we'd like to have for propagation. So a couple little things to know about these flares and coronal mass ejections. Flares are big, and CMEs are extraordinary events. Now, I just showed you a picture of the sun, but we really don't get a size of how fantastically large these events are. And I'll show you in a little bit on what that looks like. So flares, they basically generate X-rays, gamma rays. Those are all things that eventually makes its way to Earth and to our atmosphere. The things that it kind of hurts is our satellites up there. Our satellites have a whole bunch of technology wrapped in there that kind of protects them against these X-rays and gamma rays to make sure that it doesn't create a magnetic field or a magnetic pulse there called an EMP. And when that happens, it can cause some damage to our satellites. So when we get some really ugly things that happen, we can end up getting our satellites disabled or impaired as far as ability to communicate. CMEs, this is like having a big boil on the side of the sun where all of a sudden this boil just pops and all this huge amount of plasma material, billions of tons, get pushed out of the sun, and that heads off to the earth. When that happens, I'll have another slide I'll show you and show you what it does as far as what it messes up on the earth, but this can cause huge overloads to our power grid and our power systems around the earth. So here's a really neat solar flare. These are electromagnetic charge particles. You can think of this as kind of tracking what, if you have two big magnets going together, this gives you a good view of what that magnetic charge looks like as it travels between magnets. So on the surface of the sun, what happens there is that two magnetic fields of chunks of plasma that's rolling around on the surface get tangled up together and they kind of explode. Kind of, I guess it's really two opposing charges get close together and they build a big old flare like this. Now over to the right, see that little thing that says the Earth at scale? So think about the Earth. I mean, it's a really, really small thing. So that gives you some perspective and a sun is a really, really large thing. So that gives you some idea of what the size of the Earth is compared to the sun. So here I mentioned the coronal mass ejection, and this is where we have a very large amount of plasma that's ejected from the sun, travels across the space. If it ends up heading towards the poor Earth here, The Earth is off to the right and has that weird shape wrapped around it. That weird shape is the electromagnetic sphere that wraps around the Earth, that kind of protects us from all this plasma, all these hard particles, these electromagnetic fields, and it kind of bounces off or rotates or goes around the Earth. So it protects us from this huge billions of tons of plasma that's being squirted out from the sun. Now, there are times where that field can actually get broke down depending on the polarity of the material that's hitting us, because that's all electromagnetically charged material, where it can actually tear a hole in our magnetosphere. And when that happens, that charge can actually get down to Earth, and it can wrap into our power distribution system, and it can really wreak havoc. We've seen problems with it back in Canada, I think in '88 or something like that, where it knocked the grid off the air. And generally, this is not just a single event, but if we get two rapidly hits of plasma, that can really hit things. Back in the 1700s, back when we had just telegraph, that effect there was strong enough where it wrapped itself into the telegraph lines. It caused fires. It caused telephone poles to break into flames. It caused batteries that ran that system to explode. The aurora borealis at that point in time, 2 o'clock in the morning, it looked like daylight out there. Guys were getting up at 2 o'clock in the morning thinking it was time to go to work. Well, that wasn't it. That was just a huge CME that ended up hitting the Earth. And this is one of the fears that the astronomers kind of fear about, or astrophysicists, is that if we get on several really hard blasts from a CME, it can really take and wreck life here on Earth. It can get into our power system. It can destroy it completely around the Earth. You know, everything runs off of electricity, and it takes a long time to rebuild a power system like that. It can take, you know, 10 to 15, 10 to 25 years to rebuild our power system and bring it back to where it was. So what's happened in solar cycle 24? So that's the one we've just left. It basically began back in around December 2008. And this is where we had enough enough electromagnetic activity on the surface of the sun where we had kind of equal amounts of solar spots moving in one direction and another set of solar spots moving in another direction, and they were pretty equal. So that kind of dictated the beginning of the cycle. It didn't really get going until about 2012. So it took some 4+ years before we got to a point where we got sunspots, or actually, sunspots that actually got up above 20. Now this is an average sunspot. So you're averaging sunspots over a year. And we usually consider in the ham world that we need sunspot numbers to get constantly over 20 before we start having any reasonable minor propagation. So this is kind of saying that we got a little propagation, we can get a little bit of stuff done, we can have a little fun out there in the bands. So max propagations, when we start getting above that 20 level, started really in about 2014. We ended up with only about 2 years worth of decent sunspots. And our sunspots number actually averaged about 81.8 as far as the max sunspots. The maximum sunspot levels that we saw for the smooth sunspot numbers only got up to about 130. Typically on a good sunspot cycle, we're going to see that guy get up into the 140s to 225. So it really wasn't very good. Before that, these sunspot cycles, they kind of run in clusters. When you have real good ones, you're going to have probably a collection of probably at least 3. When you have really crummy ones, you're probably going to have collections of of at least 3 sunspot cycles. So this is not any big surprise. And so again, well, let's see, I'll wait till the next slide. So the lowest activity since then was back sunspot cycle 12 through 15. So it was in the 1800 to 78 to 1923. Here in this area, I mean, we only had sunspot numbers that were yearly sunspot numbers. The best we were getting is like, you know, between 3 to 9. So this was just horrible pittance, nothing out there. So as we watch what's going on in the sun, about July of last year is when we really started seeing things switch over. So that's when they said that we started sunspot cycle 25. So this is all information that is as recent as I could get in March of this year. So about a month old, a little over a month old. NOAA and NASA guys got together and they pulled off a seminar there, and they presented what their predictions are, what their findings are going to come about for sunspot cycle 25. So the cycle 25. So this is a seminar. They're predicting basically a similar size and magnitude of what happened on solar cycle 24. So it's not any big surprise. We were kind of predicting it, and so this is what we're getting. So solar minimum, we expect that that's going to, we're going to get to that somewhere around 2020. So we got to, or actually September 2020. So they're predicting by the end of this year that we're going to start seeing smooth sunspot cycle, smooth sunspot numbers that start to get above 20. I think that's over optimistic. I think that's a little over optimistic, but that's what they're predicting. So we're not going to get into the flow of things until about 2023. So we're going to have almost early in 2023. So once we get into it, we're still going to, it's going to take another 3 years before this to build till we get something halfway decent. And they're saying that it's supposed to last for about 3 years. Actually a little better than 3 years. We're expecting max sunspots, smooth sunspots of about 95 with peaks about 130. So it's going to be probably a little lower than what we had from last time. As I mentioned before, typical range, typical good solid maxes get you into the 140 to 100 to 220s. So we're not even going to get to the bottom end of things. Bottom line, it's going to look pretty much like we had the last sun cycle. So one of the things that people had kind of been pretty concerned about was, are we going to end up coming back into Munder's minimum? So this was a set of cycles that we had back in the 1645 to 1715. So that's about 70 years worth. And this is in a rare situation where we had smooth sunspot numbers that barely got into 3. That's an annual 3, and barely got up to maybe 9, between 3 to 9. So it was nothing. There was no proper propagation. Of course, back in there, we were just beginning to invent and figure out what radios were about. So hams live for RF propagation. This enables us to talk around this world. This is our caffeine. This is our adrenaline. This is what we wait for, patiently wait for. Without RF propagation, I'll have to say that some ham radios operators can get kind of depressed. I know guys that are thinking about selling off their towers, selling off their antennas, selling off their radio equipment, because without any propagation, they can't take and enjoy things out there. You know, we've had times where propagation has been so good where you can on 10 meters. You could work the world on 5 watts and an old set of gutters going around the house. But that's probably not going to happen for this condition. So current band conditions. Let's look at seeing what's going on here. We've had a couple sunspots that's popped up, but basically the sun's been pretty much void. So we've seen very few, if any, sunspots. No real activity on 15 meters. A few limited openings on 10 meters. I'll just have to say, if it wasn't for FT8 or digital modes, there wouldn't be any DXing. Pretty slim. So let's take a look at what I've done this year and see if it correlates with what everybody is kind of down on the mouth about, not feeling too good about. So this winter, I completed 6-band worked all states. I did that on 160 through 17 meters. I'm still missing 2 states. It's been 4 months, 5 months, 6 months on 15 meters that I still haven't been able to get those last 2 states to close out 15 meter worked all states. On 160 meters and 80 meters, I had a number of high value DXCC entities. I am really proud of that because one of the areas that I cleaned up house on was the west coast of Africa. I worked virtually everything across that west coast on Africa on 160 and 80 meters. Did the same on 40, 30, and 20 meters. I really added a number of good quality stuff to my DXCC. That's their credentials for, there's 340 countries and entities out in the world. And if you can get into that, I think 330 area, you get the Holy Grail. So that is the ultimate idol that every ham always worships and always tries for. So mainly, a lot of this stuff, I was working gray line. Gray line gave me phenomenal opportunities to work some really tough DX stuff. But it was so cool. The other thing I had never worked on was 30 meters. 30 meters. It's a digital band. Not many people think about it. But digital meters, or excuse me, 30 meters is a kind of a compromise band between 40 meters and 20. So it gives you kind of something in between. There's times where 30 meters is open all day long. It runs short, it runs long. You get into all kinds of different places you just can't predict. I love 30 meters. That is kind of my go-to band, where if I want to end up searching out something tough, something fun, interesting to go to, 30 meters is just a so cool place to go. So I really encourage people to take and hang some wire up in the air. And this is on wire. This is not a beam. So I really encourage you guys to take and get some wire up there and find out what's going on 30 meters. Really a cool place. So something just recently. Okay, so this season, so this next 2 to 3 months out there on 6 meters, E-skip is going to liven up. So I had someone that gave me, just wanted to get rid of it, a 6 meter Yagi. I stuck it up in the air, and I'm out there filling. 6 meters is a weird band. I mean, it can be open in the morning, and it's amazing what you can work. The last 2 nights, last night, it was open till, I know, at least 11 o'clock when I went to bed. There was all kinds of stuff going on. It's a weird band. I mean, it's open, close, open, close. Sometimes it's really hard to make contacts because there's so much fade on it. But take a look on your spotting systems and look to see what's going on. It's amazing the stuff you can get in. So I'm often tromping through 6 meters, trying to fill up my logs and get worked all states on 6 meters. So, but what else? 20 meters. So on 20 meters, I've been able to work, Europe, Asia, Africa, Oceania, South America, almost every day for this last probably um, almost a year now. But I and clear into the nights. And in the nights, it's been kind of interesting. Generally, I go to bed about 11 o'clock, but around 10:30, that's been actually picking up a little extra life. And from 10:30 to 2 o'clock, it's been amazing. I mean, I have filled up in probably 2 to 3 hours, or probably 2.5 to 3 hours. I can fill up uh, 3 log pages of entries very easily just off of 20 meters. It's amazing what you can pick off of that guy. 40 meters has been good. 3 days ago, India for us. I have yet to get India. Actually, I've yet to get a confirmation. Mongolia and India are 2 places. I've talked to guys there, but never got a confirmation. But India was wide open from the bottom to the top of India on 40 meters. You got to be there at the right place. So one of the things that this last 6 months, I've stopped looking at solar entities. So I stopped looking at solar, I don't remember what it's called, solar. Anyway, there's several places you can look to see what's going on with the sun out there. So, and that was always the thing that told me what bands should be open, when bands should be open. So that's kind of my mathematical part of my mind. That's been telling me what I should be able to work. But I've stopped looking at that. And I just go to whatever the bands are, look around it. Sometimes it can be empty, throw out some CQs and see what I can get for catching fish out there. And you just never know. I mean, there's been times where uh, I've had it pointed towards Europe in the probably around noontime, and no, excuse me, evening time. And I see a couple guys in Europe that I want to pick off. I go out there and just answer one CQ. The next thing I know, I have 3 to 6 other guys coming back at me wanting to make contact. Oregon for Europe is a rare contact. That's a hard state for them to get. Um, and the next thing I know, 3 hours have passed, and I got 4 pages of log entry in there, and I've only called CQ twice out of that whole 3 hours. So absolutely amazing. So I can always find stations to work. It's like anytime I flick on my radio, I can always find stuff out there to work. So when people say bands are dead, no solar entities, I don't care if there's sunspots or not. I can always find stuff to work. So that's just plain BS. So let's hit up the old summary here and then we'll hit some questions here. So solar cycle 25 looks to be about the same as 24. So I'll just say I'm not waiting for 25 to wake up or to do things. It's only going to make my job easier. I can say right now my job is so easy. I can go fishing and limit out in 2 hours and not have to take and break a sweat at. Actually, I do break a sweat at because I have to keep up with everybody trying to go after me. Okay, so it will be coupled by more years till we see good sunspots. So in other words, we got another 3 years before we start getting into our solar max and we start seeing decent sunspot numbers out there to really give us good propagation. Till sunspot numbers improve, need to use effective digital modes. So that's what I have been using. I have really used very little um, voice or phone out there. Practically everything has been on RIDI or especially FT8. FT8 has just opened my world up on being able to always find stuff to work out there. Okay, so this is a good time to consider upgrading your equipment, getting ready for the next solar cycle. So we got a few years till we're going to wake things up as far as getting better propagation. So um, if you want to spend some time getting like a 6-meter antenna, working on getting a tri-bander up, getting your wire higher up in the air, trying some different equipment out, this is a good time to try things out and start positioning yourself. So as those sunspots come under, you can really get out there and work a lot of stations. So sunspots will start coming back soon, but I'm not waiting for it. I'm having so much fun right now that I just there's just no end to what I'm able to take and do out there. It's a really cool. So I'm going to flip out of here, and we're going to go back to doing our shared. So any questions at this point in time? No questions? None at all? Did I put everybody to sleep?
Well, all of our Eastern folks seem to have cut out to go to bed.
Yep, I see that. So anyway, I just, the point here is that even though it's a dismal solar cycle, don't tell me that one. That if you use that as an excuse, that's a really poor excuse, because I am just dumping stuff in my logs right and left.
Hey, Mike, when you say you're dumping stuff in your logs right and left, is that mostly due to FT8 or is that a mixture?
Primarily, the primary success story has been on FT8. It has,
right.
It is kind of like one of my comments that I made there. If it wasn't for FT8, there wouldn't be any DXing, there wouldn't be any expeditions, there wouldn't be any contesting. There's some good contests that are going to be coming up that are going to be FT8 RIDI based.
But it's not like that's the only thing that's letting you talk at the moment.
It's not the only thing, but I'll say that that's my primary thing that is giving me, that's really helped me along on my DXCC, allowed me to just knock off all the states out there on worked all states, and that's the big guy that's really helped me out. So thank you guys. Hope to catch you on the air. I'm finding all kinds of buddies and friends out there, all kinds of them. So good luck.
All right. Thanks, Mike.
Yeah, thanks, Mike.
Thanks, Mike. Good seeing y'all.
Alrighty.
Yeah, thanks for hosting, Drew.
Take care.